Hello and welcome to this video on the distance formula. Today our objective is students will be able to derive the distance formula and use it to solve for the missing sides of a right triangle. In this lesson we're going to go ahead and build off of our previous knowledge with the Pythagorean theorem, and we're going to start by kind of jogging your memory on calculating the square root of a value. So the square root of 68, we can just go ahead and punch that into our calculator, getting you familiar with the square root features on your calculator. So push the second button, enter in square root, and the value you should get is approximately 8.24. So we'll just go approximately 8.2. For the second problem here in our prior knowledge, we want to find the value of x here, and this can be done with Pythagorean's theorem. We have a squared plus b squared is equal to c squared. Our c side is always the hypotenuse, so I know from this triangle here, and if I focus particularly on this side, because here we have a right triangle, this side is going to be c. Now the legs can be a or b, so I'll just go ahead and plug in 12 for c and x for b, and I now need to know this leg. Well, if this whole base is 14 and this is an isosceles triangle, then I know the altitude of the triangle is a perpendicular bisector, meaning it chops this base in half. So I have a value here of 7. So this is 7 squared plus x squared is equal to 12 squared, giving me 49 plus x squared is equal to 144. We can solve for x by subtracting 49 on each side. 144 minus 49, and we will get x squared is equal to 95. Taking the square root of both sides, we get x is equal to approximately positive and negative 9.7. We'll round to the nearest tenth. Since distances can't be negative, we'll throw away that negative value. We'll just focus on the positive 9.7. Okay? Alright, so starting our lesson, we are going to kind of develop our distance formula, and that's our objective today, to identify the distance formula. But we want to explain how we can find the horizontal distance, meaning this distance right here. And just by looking at this with a coordinate grid, we can say, hey, well, I have one point here at 1, 2, and one point here at 4, 2, so I go 1, 2, 3, a space of 3. So one method to find the horizontal distance is by counting units. And obviously that'll work as well for our vertical distance over here. But I mean, how do we get 3 without using counting? Is there another method that we can use? Well, if you notice, when I go left and right, this is my x-axis, or my x values determine my placement on my x-axis. So here I have a placement of 1 and a placement of 4. So would you say that maybe I got this by taking 4 minus 2? So 4 minus 2 gives us, 4 minus 1 gives us 3. It gives us 3. Okay, so that's one way, is to subtract the x values. So again, over here on our vertical distance, if I focus on this piece here, if I could find the vertical distance, well, again, we could count. That's one method. We can count. And another method is to subtract values. But since we're going up and down, these values are controlled by our y-axis. So one method we can do is we can subtract our y values. So 7 minus 2. 7 minus 2, and this would give us a vertical distance of 5 units. So we're going to take this idea and we're going to apply it to a regular triangle. And I'm going to have a point located here and a point located here. And we're going to ask ourselves, what's the distance between these 2 points? So if I call this x1, y1 and this x2, y2 and apply the ideas that we just talked about on the last slide, we come up with the distances of this side of the triangle and this side of the triangle as x2 minus x1. So here I have x2 subtract x1, and that would give us our values. For our vertical distance, we get our y values and we subtract them, and that would give us a vertical distance of y2 minus y1. So just like the last slide, subtracting the corresponding x and y values will give us that horizontal and vertical distance. So now that we've developed talking about distance horizontally and vertically, we're going to apply these ideas into our knowledge of the Pythagorean theorem, which is a squared plus b squared equals c squared. So say I wanted to, again, solve this distance between these 2 points, and I'm just going to call the hypotenuse this distance d for distance. And I'm going to go ahead and generate the Pythagorean theorem using these values here. So I have my vertical and horizontal distance. So the Pythagorean theorem, a squared plus b squared equals c squared. Well, if I call this the vertical distance a, so that would be y2 minus y1, and I gotta square that, right? A squared. This is a squared. And I'm going to add b squared. Well, b squared is x2 minus x1 squared. And this is going to go ahead and equal our c squared, which is d squared. Okay, so I have this, but now I want to solve for d. So what I'm going to do is I'm just going to take the square root of both sides. Take the square root of both sides. What I get here is d is equal to, and on this side I get the square root of y2 minus y1 squared plus x2 minus x1 squared. And lo and behold, this is the distance formula. So here we have it. We're going to go ahead and write this in our notes. Here is the distance formula. Square root of x2 minus x1 squared plus y2 minus y1 squared. It's okay too if you flip these. Go back. If you flip your x values and your y values, that doesn't matter. That's okay. You can have y2 minus y1 squared plus x2 minus x1 squared all underneath the radical value. You'll get the same exact answer. Okay, so we're going to go ahead and apply some of the problems with the distance formula. Here I have this triangle. Please draw this inside of your notes. And the points that we have are our b value, which is here at 1, 2, 3, 0. And our a value, which is negative 1, 2, 3, 4, 5, negative 5, comma 1, 2, 3, 4, negative 4. So these are our 2 points. And if I call this x1 and this y1, this x2 and this y2, I'm going to set up our distance formula. So we have d is equal to, well, x2 minus x1. So I'm going to subtract my x values, just like we did in the average rate of change formula, or our slope formula, which is going to be 3 take away negative 5. And I want to square this value, plus y2 minus y1. So 0 minus negative 4. And I'm going to square that quantity. All of this is underneath the square root sign. So we're going to go ahead and simplify. 3 take away negative 5 gives me a positive 8, so I have 8 squared. Plus 0 take away negative 4 is a positive 4 squared. And I take the square root of that, which gives me 64 plus 16, which is equal to the square root of 80. Okay, so I have the square root of 80 as my distance, and I want to answer that. And we're going to go ahead and round to the nearest tenth. So we're going to approximate. This is the exact answer. This is what we want. Square root of 80. But plugging this into our calculator, we would get an exact answer of approximately 8.9. So 8.9 is our answer here. That's the distance between point A and point B. Okay, we'll go ahead and try this problem. Here I have point A at 1, negative 1, and B at 1, 2, 3, 4, 5, 6, and up 1, 2, 3. So again, if I label this x1, y1, and this x2, y2, I can plug this into my distance formula. So D is equal to the square root of x2 minus x1. So that is 6 take away 1 squared plus the difference in my y's, 3 take away negative 1 squared. 6 minus 1, that is 5 squared, plus 3 take away 1, negative 1, that is 4 squared, producing the square root of 25 plus 16, which is the square root of 41. And when I plug in the square root of 41, we get an approximate answer of 6.4. Our exact length for this problem would be square root of 41. Please go ahead, pause the video here, and try this problem on your own in your notes. Okay, so hopefully you've tried this. 2, 3, 4, negative 2. So I have a point here at 4, negative 2, and a point over here, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6, negative 6. I'm going to label this point x1, y1, this point x2, y2, and I'm going to plug in, giving me 6 take away negative 4 squared plus negative 6 take away negative 2 squared. This simplifies to 6 take away negative 4 is 10 squared. Negative 6 take away negative 2 gives me 4. Negative 4 squared. So negative 4 squared. And this gives me 100 plus 16, which is square root of 116, which is approximately 10.8. Okay, that's our